So again, what I was saying about that overestimate was if you draw this, here's the overestimate, here's the underestimate. Okay, so you're asking for 12 again? What were you asking on 12? Let's actually do it here. So it says, use theorem temper 1 to bound the error. It asks, use the Taylor by a Taylor point of degree 0. It tells you the degree.
So then,
Approximation sine theta is equal to theta from -1 to 1. So if you actually graph this, and let's see if you can do better than my other class, they let me graph the entirely wrong visual approximation of sine. Maybe they thought I was there. I don't know. Who knows? What does sine look like? What is sine 0? 0. So sine starts here, and what is it? It starts there, and what does it do? It goes up and then down, right? It also does that. You with me? And then what would the function y equal theta look like? It kind of looks like this. The scale's a little off. But this right here is theta, and this right here is sine theta, like that. And you're going from 0 to 1. Is it actually a decent estimate from 0 to 1? It's not bad. It's not like going off in the wrong direction. So it says, using informal reasoning, say where the approximation is an overestimate. Where does it look like the red line is above the blue? Where does it look like it's an overestimate? Well, at 0, it's equal to it, right? So it's not going to be an overestimate. 0 to what? 1. Where does it look like it's an underestimate? -1 to 0. Correct. So it looks like it's an overestimate to the right, and it looks like it's an underestimate to the left. Great. What's that big statement involving m? What is it? M over what? So you start doing this, and you're like, oh, okay, so we just need to plug in values here, and usually the first thing you try to get is n, correct? You need to figure out what n is. Here's the thing. It doesn't tell you what n is, but it tells you what the approximate function is going to be, which is theta, right? What is the expansion of sine theta? What's the first term? Not x. What is it going to be in this case? Theta minus what? Theta cubed over 3 factorial plus theta to the 5th over. So it keeps going, right? Agreed? Is everybody with me so far? So what does it tell us we're using for our approximation? Just what? Just that. Now the big question that came up in my last class was, do we say n equals 1 or n equals? No. It's definitely n is. Oh. Could it be n equals 1 or n equals 2? Why can you say n equals 2 on this one?
Because the coefficient for the second degree term is 0.
Correct. Correct. So go up. Go up on it. Go up. So I haven't come up with a really, really good reason for this, but for example, you might be asked on the AP test, what is the second degree Taylor approximation of sine? And you would just say, it's theta in this case. But that still would be considered the answer to what is the second degree. So use the larger one. If you did with one, on this question, if I gave this to you on a test and you use 1, I'd give you credit. If you use 2 for your n value, I'd give you credit. But in this case, let's use 2. If we use 2 on this one, we now say, okay, n is 2. Nice. And I'm going to use something other than the highlighter. N equals 2. What's our a value? I think it tells us, right? What is it? 0, because we use this, right? What is that centered around? 0. Now the real question is, what is your x value, right? That's what your question is. Like, what are we calculating the error for? Well, here's the thing. It's not asking us to calculate the maximum error at a specific value. It's asking us to calculate the maximum error on the entire interval. And that's where this picture comes into play. Where is the maximum error going to occur? There's 2 places. What's one of them? Where's the maximum error going to occur? 1 or -1. Either one. Now, does it matter when we plug in 1 or -1? Not really. It's being raised to the 3rd power, right? Because we chose n equals 2. But why does it not really matter about the absolute value? We can put the absolute value in. Why does it not matter if we use plus or minus 1 here? Well, it's to the odd power, so it'll be positive or negative, but you're taking the absolute value of it, is what I'm trying to say. Both of these, plus or minus 1, result in the same error, because this graph right here, is there a whole lot of symmetry right here? Yes, sine is an odd function. This is symmetric over the origin, so this distance here is going to be the same distance as this distance here. That's what I'm saying. So now when you do this, you've gotten it down to just needing the m value, and it's m over 6. You with me so far? But now you need to know what m is, and what was that inequality for m? F what? N plus 1. So an n plus 1 in this case is going to be 3 of x less than or equal to m. But what's the interval we're dealing with here? -1 to 1. So at this point, what do you need to find? You need to find the actual third. We need to find the actual what? What does f3 mean? So we need to find the actual third derivative. So let me finish my sentence. Everybody's tracking what I'm saying. We'll go back to your question in 1 second, okay? What was f of x in this case? Well, not f of x. I'm sorry, I should not use x. It's f of what? Theta. So what was f of theta in this case? Sine theta. Okay, we'll pause here for 1 second. Yes, Nate? We can do it both ways. F of theta is sine theta, so what's f prime? Cosine theta, so what's f double prime? Negative sine theta. And what's f3 here? Negative cosine theta. Correct. So if we want the absolute value of this to be greatest, this is the function. If we want the absolute value of that to be greatest, where does that occur? So we're looking for, we have the absolute value of negative cosine theta. The derivative of sine is cosine. The derivative of cosine is negative sine. Sorry, so the derivative of negative sine is negative cosine, because the negative is out front. The derivative of sine is cosine, right? So we got to the right place. I forgot the negative. So what is the absolute value of cosine? A negative cosine is going to be just cosine. So the question is, where is cosine maximized from -1 to 1? Because it's concave down at x equals 0, right? So this is max when theta is what? 0. So we plug that in, and what is cosine of 0? 1. So where do we plug that in? There. So our maximum error is 1/6. I gave you, for example, if I said, remember this, f6, 0 over 6 factorial x to the 6th. Do you remember that from the Taylor expansion? Right, that would be this right here is the coefficient of x to the 6th, correct? Parts A and B lead you to actually make the Taylor expansion. I think it is for sine of x squared plus cosine x. I think that's the question, right? You do direct substitution for sine x squared, and you just add in the cosine. You actually have to simplify it. Some of you ignored the fact that it's just the first 4 terms and wasted a bunch of time writing out lots of more terms. The first 4 terms, you just do the first 4 terms. The last term, if you do the first 4 terms when you do this, is x to the 6th times something like this. There's something attached to it. So if you have something in front of x to the 6th, can you figure out what f60 is? You're asking for that right there. You're asking for that right there. If you do it out, if you actually simplify it out, you end up with 6 factorial, and it's like -121 if you actually simplify it correctly. Some of you got 119, which is you messed up the sign on one of them. But I think it's something like plus, it's like it's x to the 6 over 3 factorial and negative x to the 6 over 6 factorial. I think that's what the math is. I can't remember, so I'm not going to keep that there. But if you actually simplify it out, this is the term you get for x to the 6th. So therefore, what number do you want? -121. It's just the numerator above 6 factorial. You guys, for some reason, remember, it was really amazing. Some of you cranked through the first part and then started from 0, like started from the beginning again and tried to make the actual Taylor expansion starting from 0. Like started writing out the derivatives. Like some of you started with like this as your f, and then what did you do? Took the derivative and again and again. Don't do that. You had already done it in the first 2 sections. You had built it, and if you had built it properly, this is what you would have had right there. Yes, Sujon?
Why is it working?